ladies and gents. This is our second lesson of this week, and as I said, we're going to carry on with limits, but now we're looking at limits at infinity. What does that mean? Okay. So far we looked at the limit of a function when x approaches a certain value, a finite value, a. That a could be 2, minus 5, 17,802. Okay, it doesn't matter, but it's a finite value. What happens to the value of the function as x approaches to infinity? Okay, so we're just going to go through a bunch of function, coming harder and harder and harder, but actually it's not a really difficult concept. So we'll start with a horizontal function, f of x equals c. Okay, c could be 3, 2, minus 1,700. 17,000 million gazillion. I sound like some politician now, right? Anyway, so what happens to that value as x approaches infinity? How do we write it? What is the value of f of x when x approaches infinity? Okay, that's the sign for infinity. That is lying down 8. Okay, and the answer is obviously c. Okay, because if it's a constant function, okay, you just think, okay, so as I go to infinity and infinity, well, the f of x is always c, so it doesn't matter. So that's pretty easy, right? Now, have a look at this. Okay, we worked with this second function, hyperbola, but so far we looked at what's the limit of the function when x approaches 0. Okay, and we knew that the answer is infinity. Okay, there is no finite value; it blows up to infinity. In fact, the limit doesn't exist. I need to talk about whether I'm approaching 0 from the right or from the left. Because if I approach from the right, it's in plus infinity. If I approach from the left, it's minus infinity. But actually now, I don't want to check at 0. I want to check at infinity. Okay? So what happens to the value of that function when x gets closer and closer to infinity? When I'm increasing x, what happened to f of x? And you know the answer for that. Okay, you know it's called an asymptote. Okay, this line gets closer and closer and closer to 0, but it never really reaches it. Okay, we said that there is an asymptote. The x or the y equals 0. Okay, this is the line y equals 0. Okay, is an asymptote. What does it mean? That as x approaches infinity, the y becomes closer and closer to 0. Okay, all right. So as x approaches to infinity, the value of that x, okay, becomes closer and closer to 0. So the limit is 0. Okay? So sometimes the limit at infinities can be a finite number. Sometimes they can be 0 as well. Okay? I'm just going to make some space. Yeah, I'll just pause here for a second. Okay, next thing we're going to look at is this function. 1 plus x divided by x. Okay, I'm not going to draw it just yet. Let's just think about it. And I want to find out what's the value of that function, or the limit of that function when x approaches infinity. How do we do that? How do we do that? Now, I could just say, naively, maybe you can say, all right, let's just put infinity instead of x. So I'm going to write 1 plus infinity divided by infinity. Okay? 1 plus infinity divided by infinity. Infinity and 1 divided by infinity. How much is that equal to? I don't know. I'm actually really curious to know what you can come up with. Think about it. Just pause me for a second. What is that? What is it equal to? Really would love to know what you can guess. Anyway, let's see how we're going to get to that function. Your intuition might very well work well. So what I'm going to do, I'm going to rewrite this function like this. I'm going to write it as 1 over x plus 1, right? I just divide 1 over x plus divided by x, it's 1 over x plus 1. Now 1 over x plus 1, I know how to do it. I mean, what is 1 over x plus 1? It's 1 over x, and then I vertically shift it by 1. So it's going to be like this, right? So I've got now an asymptote, horizontal asymptote. I still have the vertical asymptote at 0, but I have a horizontal asymptote at y equal 1, right? Because I moved it up at 1. So now if I know, what does it mean, the limit at infinity? It means what is the value of y as x approaches infinity? Well, I know the answer. It's going to be 1, isn't it? Okay? Because x goes to infinity, gets closer and closer to the asymptote y equal 1, never really reaching it. But the limit is y equal 1. So the answer here is limit, or I'll write it down, x approaches infinity, 1. Okay? Now, that could very well be what you came up with. Maybe. Because 1 plus infinity is still infinity. Okay? Still infinity. And infinity divided by infinity is 1. Okay? But this is kind of an intuition, and it can be risky. So the way the book teaches you to do that is the way I will tell you now, is the safest thing. So one way is just what we did. We try and create a picture image of what the function is, and if we find kind of an asymptote, okay, then that will be the value of the in infinity. But an easier way goes like this. Okay. So what you got to do is, and this is the rule, okay, when you've got a fraction, okay, what you want to do is divide by the highest power of x. Okay? So in this case, I just have x power 1. So I'm just going to divide the top and the bottom by x. So I'm going to say, okay, 1 plus x divided by x divided by x divided by x. So that's going to be 1 divided by x plus 1, right? 1 divided by x plus x divided by x, which is 1, divided by x. Sorry. Dividing by x. I made a mistake. I should have divided by x. Dividing the top and the bottom by x. Okay? So x divided by x is 1. Okay? Now, I'm going to substitute it. Okay? So I'm fine. I'm going to rewrite it. It's the limit with x approaches infinity. 1 over x plus 1 divided by 1. So now I substitute infinity instead of x. Okay? The idea was to get rid of all the, okay, you'll see it in a second. So I'm going to put infinity instead of x. I'm going to write 1 divided by infinity plus 1 divided by 1. And now this is the crucial moment. This is the thing that you need to just remember. 1 divided by infinity. What is 1 divided by infinity? I have 1 cake divided by, let's say, 1 person. So the person will get the whole cake. 1 cake divided by 2 people. Each one will get half a cake. 1 cake divided by 10 people. Each one will get 0.1 of the cake. If I have 1 cake and divide by infinite amount of people, everyone will get a 0. Okay? So that is probably the crucial thing to remember here. Maybe one of the 2 crucial things. The first one was we divide by the highest power of x in the fraction. Secondly, whenever I have 1 over infinity, 0. Okay? So now I can write that as, what is that? 1 over infinity is 0 plus 1 divided by 1 is equal 1. Whew, quite a lot, eh? Okay, let's pause here and I'll put some more examples. Okay, so that was a little bit of a tricky example where we had a fraction. So we're going to leave that for a minute. We'll come back to that in a minute. But first of all, a few simpler examples, okay? So the next one is just a straight line, okay? Straight line is something like ax plus b. F of x equal x plus b. What is going to be the limit at infinity? Well, when x goes to infinity, okay, either the answer, it's either going to go to plus infinity or to minus infinity, okay? It's straight line. It doesn't stop, okay? So it's going to be plus minus infinity. Obviously, it depends on a. If a is positive, it will be plus infinity. If a is negative, it will be minus infinity. The next one, you can look at, what do you call it? Parabola, okay? Square. What do you call it? The quadratic equations. Maybe cube, power 4, power 6, power whatever. So I'll call it a polynomial, okay? It's going to be a to the power, ax to the power of 1,000 plus bx power 100, whatever, polynomials, okay? X to the power positive values, okay? What will happen here, if you think a little bit about that, again, it is going to go either up to positive infinity or to negative infinity, depending on the leading constant. I don't want to get into it too much because it doesn't look like you really need to know it, but just like a parabola either goes up to plus infinity or goes down to negative infinity, and it all depends on the a in front of x squared, okay? So it's always that constant before, not the constant, the coefficient of the leading value of x, okay, the leading meaning the highest degree. Okay? X squared is the highest in a parabola. X cubed is the highest in a cube, and so on. That will determine when it's going to go to infinity or plus infinity. Okay? Yeah. Let's just do one more. What about f of x equal 1 over x squared? Okay, so we dealt with 1 over x squared. 1 over x, what happens when it's going to 1 over x squared? Okay, and we're trying to find out the limit, the function, when x approaches infinity. Okay, again, I think you guys can answer that pretty easily. Okay, what happens to f of x when x approaches infinity? Okay, I think you'll figure out easily that it goes to 0, isn't it? But in case you don't see it straight away, let's write it down, okay? I can write 1 over x squared if I want to. It's going to be a bit weird, but you can write it as 1 over x and that's squared. Okay? Now, then I can put in the infinity in there, so it's going to be 1 over infinity squared. And 1 over infinity, we're remembering, that's probably the most important thing I need to remember from this lesson, is 0. And 0 squared is 0. Okay? So 1 over x squared, the limit also is 0. What is the difference between 1 over x squared and just 1 over x? Okay, let's say I have g of x, which is 1 over x. They're both, the limit at infinity is 0. What is the difference? Can you think about what's the difference? Again, it's beyond what we really need to know. But that square means that f will get to infinity faster than g. Okay, let's draw that. Okay, I don't want to get into too much of details and proofs and stuff, but I think it's quite interesting. Okay, so g of x, I'll draw in red. G of x looks like this. This is g of x. Obviously, you've got the other side here, but I'm not too bothered with that. Okay, f of x, because you've got that square, it means it's going to get closer to infinity more rapidly. Okay? More rapidly. Right, I'll pause here, make some space. We're going to go to a final example. Okay, so when we have polynomials, okay, x squared, x cubed, just x, okay, as x approaches infinity, the y will also approach infinity or minus infinity. Okay, if f is just horizontal, f of x equal 5, at infinity, the limit will also just be 5. Okay, if we have x at the bottom, so 1 over x, 2 over x, 3 over x squared, so it doesn't matter if it's squared, as x approaches infinity, f will go to 0. What happens if we have something at the top, a polynomial at the top, and a polynomial at the bottom? So we've got fraction. So what you got to do is what I told you before, which is the second rule to remember from today, is you got to divide by, correct, the highest power of x. So we're going to divide both the bottom and the top by x squared. Okay? I'm going to put it like that. We're going to divide both the top and the bottom by x squared, because the x squared is the leading power. Okay? In this case, the leading top and the leading bottom is the same, so we divide by x squared. But if we had, we'll see in a minute where one is higher, we'll always divide by the leading x, power of x. Okay, so we're going to divide by x squared, it's going to be 2 plus 3x divided by x squared is 3 over x, minus 1 over x squared. Okay, just divide by x squared each one of these terms. And now I've got to do the same thing here. Okay, so that's going to be minus 3. Minus 2 divided by x, minus 5 over x squared. All I did is divide each one of these terms and these terms by x squared. I can do it, right? Whatever I do to the top, I do to the bottom. What did I achieve with that? By the way, I should have really written here, that was a bit naughty of me. Every time mathematically speaking, if you write it properly, okay, you know what, I'm just going to do it. This is the first time I show you, okay? I must always write that limit business. I can't. It's very annoying, but you have to do it. You have to do it. You have to write the limit, because we're looking at the limit when x approaches infinity. So now I'm going to write it again. So it's going to be 2 plus 3 over x minus 1 over x squared divided by minus 3 minus 2 over x minus 5 over x squared. Okay? At the limit where x approaches infinity. Now, Okay, when I got rid of all the x's, well, I've got the x's, but they're in a denominator. Now I can put the infinity. Why? You'll see in a second. So that's equal, don't forget the limits. X approaches to infinity. Okay, 2 is just 2. Plus 3 divided by infinity minus 1 over infinity squared. Okay, divided by minus 3 minus 2 over infinity minus 5 over infinity squared. Yeah, okay. And now we know how to do it. Okay, because 2 just remained 2. What is 3 over infinity? 0. What is 1 over infinity squared? 0. What is okay, here we have minus 3. What is 2 over infinity? 0. What is 5 over infinity squared? It's 5 over infinity, which is 0, divided by infinity. 0 divided by infinity. You have obviously 0. Okay? Let me just write it for you here, because I know that's a bit more confusing. 5 over infinity squared is 5 over infinity, divided by infinity, right? Or times infinity on this side, okay? What is 5 over infinity? Is 0. Divided by infinity, well, if anything divided by infinity is 0, then definitely 0 divided by infinity is 0, okay? The biggest star, the biggest thing that you really need to remember here, that a, where a is a finite number, divided by infinity is always going to be 0. That's the main thing. Okay? So what's the answer? 2 over minus 3 or minus 2 over 3. Okay? So the limit of that function is minus 2 over 3. Let's do a couple more. I'll put a couple more. Okay, so now we're looking again at a fraction. All the difficult bit is when we have a fraction, a polynomial at the top, a polynomial at the bottom. And now the leading power of x is actually at the bottom. They're not the same top and the bottom. We have x here, and now we have x squared. So what we're going to do, we divide by, and that's the first rule, divide by the highest power of x. So in this case, I'm going to divide by x squared divided by x squared. Obviously, I have to do the numerator and the denominator. I can't just do one of it, okay? So now I'm going to have x divided by x squared minus 3 divided by x squared. And not forgetting, I got to write down the limit, okay? X squared divided by x squared is 1. Actually, guys, if you don't mind, I'll just do x divided by x squared is simply 1 over x, isn't it? It's just, you guys are AP maths, you can figure it out, okay? X divided by x squared, 1 over x. 2x divided by x squared plus 2 over x minus 5 over x squared. Okay? Now what do we do? Once we've done that, we divide by highest power. Now we substitute x equal infinity. Okay, so that's equal to limit 1 over infinity minus 3 over infinity squared divided by 1 plus 2 over infinity minus 5 over infinity squared. That is very clearly 0, 0 minus 0. And that is 1 plus 0 minus 0, so the answer is 0 divided by 1, which is 0. Okay? Alright? So, yeah, if you follow these rules, then you'll be safe. If you want to be a little bit more risky, but I would suggest do these rules. But you can start developing this idea is that, look, all these x's goes to infinity. Okay? Because I've got x equal to infinity, I'm going to have infinity, lots of infinities. But not all infinities are equal. Okay? Some infinities are more infinite than others. Okay? Because I have x squared, it approaches infinity quicker. Okay? Approaches infinity quicker. Yes. So the denominator is always going to be larger than numerator. Okay? It's x squared. Okay? Forget about all the other ones. It's x divided by x squared. Forget about the lead. You just look at the leading one. So then you can predict, because the denominator is always going to be stronger infinity than the top, okay, it's going to be 0. Okay? But probably better be just safe and go with the program. Let's do one last example. Right, last example. So I've got x cubed minus 1 divided by 100x squared, 200x plus 1000x. So you can see now the leading x is the top. At the bottom I have up to x squared. But I've got like a large number, 100 and also 200x. Which one is stronger? Okay, which one is going to be stronger? The numerator or the denominator? Okay, just think about it. We'll answer it in a bit, but we'll go according to the rules. So the first thing to do is divide by the highest power of x. So in this case, it's x cubed. I'm going to divide by x cubed, top and bottom. Okay, that's going to be equal to x cubed by x cubed is 1 minus 1 over x cubed divided by 100x squared divided by x cubed is 100 divided by x. 200x divided by x cubed is 200 divided by x squared plus 1000 over x cubed. Now, next thing, what do we do? Substitute the infinity. So it's going to be 1 minus 1 over infinity cubed divided by 100 divided by infinity plus 200 divided by infinity squared plus 1000 divided by infinity cubed. Okay, what do we get there? Look at that, I forgot the limit. I should write the limit. Okay, so limit x approaches infinity. Right, we got 1. What is 1 over infinity cubed? 0. Divided by 100 divided by infinity? 0. 200 divided by infinity squared? 0. 1000 divided by infinity cubed? 0. We're going to get 1 over 0. What is 1 over 0? Okay, we did have that debate a while back. Okay, you've got, I don't want to repeat again, but if you've got a number, a finite number, divide by the smallest number ever, smaller than that, because 0 there's nothing smaller than that, okay, in absolute value. Okay, so 1 divided by 0 is infinity. Okay, it's infinity. Okay, maybe that's the other thing that you should really remember here. If I've got a divided by 0, that is going to be infinity. And I'm going to let's just do that now. Just going to pause you for a second. Okay, if you don't have the intuition why is this the case, I can show you that here. So a over infinity equals 0. This, I think we have a good intuition. Now what I can do then, I can divide by the equation. So I'm going to write 1 over infinity is equal to 0 over a. And 1 over infinity equal to 0 over a. Now what I'm going to do, I'm going to flip it. Okay, I'm going to power both sides by -1. Okay, I'm going to flip them, just like I flip always. I can always flip. So I'm going to write infinity divided by 1 is a over 0. What is infinity over 1? It's just infinity. So a over 0 is infinity. So that's just another way to kind of get that feeling. And before I say goodbye, I don't know if you guys guessed that it's going to be infinity. Okay? The leading power was in the numerator, x cubed. Here we only have up to x squared. Now I deliberately put these big numbers, 100, 200, 1000, to kind of boost it up, to make it bigger. But you can see these numbers mean nothing. Exponents are much stronger. All these numbers, these big numbers, when are divided by infinity, are 0. Okay? So it's basically the side, the top or the bottom, that have the leading power of x. He's the one who wins. Okay? If the top is higher, then the answer is going to be infinity. If the bottom is higher, okay, like here, then it's going to be 0. If they're the same, then we're going to have to divide by the coefficients of these x cubed. Right, I'll stop now. Guys, do your exercise. Let me know on WhatsApp if you need some help.